Nature of matter. 1.0 Introduction. The Earth, and every substance found on it, is made up of matter. This book, your desk, the air we breathe and the water you drink are all examples of matter. Some matter is living, some non-living, some matter is man-made and some natural. We can say that all substances are made up of matter. Connect with me via WhatsApp, +234 703 247 4726, to get more interesting videos. Please, to support our ministry, remember to like the video, and also find it in your heart to subscribe to our YouTube channel and then gently tap the bell to turn on the notification, so as not to miss out on the next videos. 1.1 Matter. Matter is anything that occupies space, has mass and can be perceived by our senses. Thus, matter has mass, occupies space, and can be perceived by our senses. In other words, we can touch, feel or see it. For example, sand is matter. Sand has mass, occupies volume and can be seen and felt by us. Milk is matter. Milk has mass, occupies volume and can be seen and tasted by us. 1.2 Characteristics of matter. The important characteristics of matter are that matter has mass, occupies volume and can be perceived by our senses. We will show these characteristics by conducting experiments. 1. All matter has mass. This can be proved by the following experiment. Take two balloons. Fill one with air and keep the other empty. Tie these two balloons to the two ends of a scale. Try to balance the flat surface of the scale on an edge from the middle. The observation will be that the scale tilts towards the side having the balloon filled with air. The inference or conclusion is that, as the balloon filled with air has more mass, the scale tilts towards the side having the balloon filled with air. This shows that air has mass. 2. All matter occupies volume. This can be proved by the following experiment. Take a tumbler and fill it to the brim with water. Now, slowly immerse a stone into the water. The observation will be that some water spills out of the tumbler. The inference or conclusion is that water whose volume is equal to the volume of the stone flows out of the tumbler. This shows that the stone has volume. 3. Matter can be perceived by our senses. When we move on a cycle, we can feel the air on our face. We can see a stone, water, sand, etc. The inference or conclusion is that matter can be perceived by our senses. 1.3 Quantity of matter. Mass. A large rock is heavier than a smaller piece of rock. The quantity of matter is more in the large rock than in the small rock. The more the quantity of matter in an object, the greater is its mass. The quantity of matter in an object is called mass of that object. The quantity of matter equals mass of that object. Weight. We often use the words mass and weight interchangeably. Generally speaking, if mass is more, then weight is also more. But the two terms do not exactly mean the same. Mass and weight are different from each other. We often find our weight by standing on a weighing machine. Have you checked your weight recently? Some of your friends may be having more weight than you, while others have less weight. What is weight? All objects when left free in the air, fall down. Weight is the force with which the object is pulled towards the earth due to gravity. Have you wondered why they fall down? All objects are pulled by the earth, by a force called gravity. Heavier objects have more mass and are therefore pulled more strongly by gravity. So, heavier objects are said to have more weight when compared to lighter objects. Let's check out an experiment. Take two bricks of the same size. Break one brick into two. Take the larger brick and one of the smaller pieces of bricks to the top of a building. Take the smaller brick in one hand and the larger brick in the other hand. Drop both the bricks down at the same time from the top of the building. The observation will be that the larger brick strikes the ground a little earlier than the smaller brick. The conclusion is that the larger brick is pulled more strongly by the earth. The weight of the larger brick is more as the quantity of matter is more in the larger brick than in the smaller brick. Mass and weight. The mass of a body does not change because the quantity of matter does not change. Mass of a body is a constant. In other words, the quantity of matter is a constant. But the weight of a body differs from place to place. For example, a body that weighs 6 kilograms on the Earth will weigh 1 kilogram on the Moon. The weight of a body is not a constant and varies from place to place. 1.4. Classifying matter. As there are so many different types of matter around us, it will be easy to study matter if we group different types on some similarity. For example, all matter can be divided into two broad groups: living and non-living. Living matter can be divided further into plants and animals. Non-living matter can be divided further into natural and artificial matter. This way of grouping is too broad, and we will see a more specific way of grouping matter. 1.5. States of matter. Matter can be classified in different ways. One of the ways of classifying matter is given above. Another way of classifying matter is based on its physical state. Matter can exist in three physical states: 1. Solids. 2. Liquids. 3. Gases. All matter that we know can be divided into these three states. For example, a gold ring is a solid, water is a liquid, and air is gaseous. We will now study the states of matter in more detail. 1.6. Solids and their characteristic properties. 1. All solid matter has mass. When a solid is placed on one side of physical balance, the other side being empty, the balance tilts to the side having the solid. 2. All solid matter occupy space. When a solid is dipped into a measuring jar partly filled with water, the level of water rises. When a larger object is dipped, the rise in level is more. 3. All solids have definite volume. When a solid is dipped into a measuring jar partly filled with water, the difference in readings before and after dipping gives the specific volume of the object being dipped. When a larger object is dipped into water, the difference in readings is also larger. 4. All solids have a definite shape. The ice cube can fit into a small tumbler, whereas the rock cannot fit into it. This shows that the shape of the solid is rigid. Also, solids can have any number of free surfaces. 5. Solids cannot be compressed. They have a rigid shape that ordinarily does not change. Sponge is also a solid, but it has many pores in it. Air is present in these pores. When you squeeze it, air moves out of the pores, but when you leave it, air again fills up the pores. All the particles in a solid are closely packed. They cannot be brought any closer. A book, for example, even if pressed very hard with the hands, does not change shape. A sponge is compressible as it has air spaces in between. If a very high pressure is applied to a solid, it may break, but its size does not change appreciably. Solids are incompressible. 6. Solids do not flow. Take some pebbles. Keep them on a flat table. Do they change their position? They do not change their position, as pebbles are in the solid state. Solids do not flow. Summary of the properties of solid. All solids have mass. All solids occupy space. All solids have definite volume. All solids have definite shape. All solids are incompressible and have rigid shape. Solids do not flow. A solid has definite mass, volume, shape, and can have any number of free surfaces. Examples of solid matter: stone, wood, iron, steel, gold, diamond, stones, etc. 1.7. Liquids and their characteristic properties. 1. All liquid matter has mass. If a glass tumbler with some liquid in it is kept on one side of a physical balance, and a similar tumbler that is equal in mass is kept on the other side, the balance tilts towards the tumbler containing the liquid. 2. All liquid matter occupy space. Pour a little water into a measuring jar. Take the reading coinciding with the upper surface of water. The readings show the amount of water in the jar. This shows that liquids occupy space. 3. All liquids have definite volume. Take a measuring jar with some water in it. Take the reading coinciding with the upper surface of water. Pour a little more water. The level of water rises. Take the reading again. The difference in the readings is the amount of water poured into the jar the second time. This shows that a liquid has a definite volume. 4. Liquids do not have definite shape. They take the shape of the container in which they are kept. A given quantity of water, say, 100 milliliters, can be poured completely into different shaped containers. The volume of the water is the same, but water takes the shape of the container. 5. Liquids can be compressed to a very small extent. A milk sachet can be compressed to some extent. 6. Liquids can flow. Liquids can be poured from one container to another container in a smooth flow. The flow is always from a higher level to a lower level. Summary of the properties of liquid. All liquids have mass. All liquids occupy space. All liquids have definite volume. Liquids do not have definite shape. Liquids are compressible only to a very small extent. Liquids can flow. A liquid has definite mass and volume but no definite shape and has one free surface. Examples of liquid matter: petrol, kerosene, groundnut oil, water, sugar solution, etc. 1.8. Gases and their characteristic properties. 1. All gaseous matter has mass. A filled gas balloon is heavier than a similar gas balloon that is empty, as the air inside the filled gas balloon has mass. 2. All gaseous matter occupy space. When an empty glass tumbler is pushed upside down into water and tilted, gas bubbles can be seen rising to the surface of water from the mouth of the glass. 3. Gases do not have definite volume. The piston can be moved up or down. This shows that volume of air can be changed. 4. Gases do not have definite shape. They take the shape of the container in which they are kept. 5. Gases can be compressed to a great extent. Press a filled balloon with your fingers. The balloon can be compressed. 6. Gases can diffuse, flow in all directions. A glass jar containing only air is inverted over a glass jar containing nitrogen dioxide, which is brown in color. After some time, the brown color spreads to both ends of the jars. This shows that the brown gas has flown upwards. This also shows that gases can diffuse, move in all directions, even upwards. Summary of the properties of gases. All gases have mass. All gases occupy space. Gases do not have definite shape. Gases do not have definite volume. Gases can be compressed to a great extent. Gases can diffuse. A gas has definite mass but no definite volume or shape and no free surfaces. Hydrogen, nitrogen, oxygen, carbon dioxide, steam, etc. are all gases. 1.9. Matter is made up of small particles. Just imagine that matter is divided into smaller and smaller pieces till no further division can take place. All matter consists of very small particles that cannot be further divided into smaller particles by normal methods. Solids, liquids, and gases are made up of very small particles that cannot be divided further by normal methods. Let us take a look at the solids. In solids, the small particles of matter are very close together and touch each other. The particles are so close that not much movement can take place. There is very little space in between the particles. Looking at the liquids. In liquids, the small particles of matter are a little farther apart when compared to solids. They do not touch each other. There is more space in between the particles when compared to solids. The particles have more freedom of movement than solids. They can move in the spaces in between, pushing other particles, colliding with them, changing direction constantly. Then, let us talk about the gases. In gases, the small particles of matter are still farther apart when compared to liquids. They do not touch each other. There is more space in between the particles when compared to liquids. The particles have maximum freedom of movement. They can move in the spaces in between, pushing other particles, colliding with them and changing direction constantly. 1.10. Differences between solids, liquids, and gases. We have just seen the characteristic properties of each of the three physical states: solids, liquids, and gases. Now we will compare the characteristic properties of solids, liquids, and gases. There is a table to put out the different characteristic properties of solids, liquids, and gases. From the table, at a glance, we can see that solids, liquids, and gases have mass and occupy space. And that, while solids have definite shape and volume, liquids do not have definite shape but have definite volume, and gases have neither definite shape nor definite volume. Also, while solids cannot be compressed, liquids can be compressed only to a very small extent, and gases are highly compressible. The final sets of things to note is that solids do not flow, because distances between the particles are very small. Hence, there is minimum movement of the particles. But liquids flow from a higher level to a lower level, because average distances between the particles are more than that in solids, and less than that in gases. And movement of particles in liquids is more than that of solids, and less than that of gases. Whereas, gases flow in all directions, because average distances between the particles are maximum. Thus, gases have maximum movement of particles. 1.11. Interconversion of states of matter. Water is a liquid under ordinary conditions, but when a glass of water is kept in a refrigerator, it changes to ice. This happens because it has been cooled. But when we heat water, it starts boiling and changes to steam. Similarly, steam, on cooling, changes to liquid water, and so does ice, when kept at room temperature. Change of state. Matter can be converted from its solid state to its liquid state, or vice versa. Similarly, matter can be converted from its liquid state to its gaseous state, or vice versa. This conversion is called change of state of matter. The change of state of matter is brought about by changing the temperature. Change of state on heating. Let us talk about melting. The change of state of matter from its solid to its liquid state on heating sufficiently is called melting. While, about boiling. The change of state of matter from its liquid state to its gaseous state on heating sufficiently is called boiling, or vaporization. Change of state on cooling. Let us now talk about freezing, or solidification. The change of state of matter from its liquid state to its solid state on cooling sufficiently is called freezing. While, about liquefaction, or condensation. The change of state of matter from its gaseous state to its liquid state on cooling is called liquefaction. Change of state on changing temperature. First of all, let us talk about heating matter. Based on melting point. The temperature at which a solid, on being heated, starts to change to its liquid state, is called melting point. While, based on boiling point, the temperature at which a liquid, on being heated, starts to change to its gaseous state, is called boiling point. Secondly, we talk about cooling matter. Based on freezing point, the temperature at which a liquid, on being cooled, starts to change to its solid state, is called freezing point. Based on condensation point, the temperature at which a gas, on being cooled, starts to change to its liquid state, is called condensation. Points to remember. The freezing point of a matter in liquid state, and the melting point of the same matter, in its solid state, has the same numerical value. For example, the freezing point of water is 0 degrees Celsius, and the melting point of ice is 0 degrees Celsius. The boiling point of a matter in liquid state, and the condensation point of the same matter, in its gaseous state has the same numerical value. For example, the boiling point of water is 100 degrees Celsius, and the condensation point of steam is 100 degrees Celsius. Let us look at the illustration which shows that matter changes to its solid, liquid and gaseous state. Sublimation. Some matter change directly from their solid state to their gaseous state, or vice versa, without passing through the liquid state. This process is called sublimation, and these substances are called sublimates. Examples: camphor, iodine, dry ice, solid carbon dioxide, and naphthalene. 1.12. Properties of matter. Matter differs from other matter in several ways. Some of the differences are shape, size, and color. There are many other differences between different kinds of matter. Shape, size and color are called properties of matter. There are other properties of matter. Physical state at room temperature. Matter can exist in three different states: solid, liquid, and gas. At room temperature, wax is solid, water is liquid, and carbon dioxide is gaseous. In terms of color, each matter has its own unique color. For example, water is colorless, milk is white, and copper sulfate solution is blue. In terms of shape, matter in its solid state may be crystalline or amorphous. Examples of crystalline solids: common salt, sugar, alum, blue vitriol. Examples of amorphous solids: coal, wax, clay, talcum powder. In terms of odor, smell, some matter is odorless, while others have a specific odor. Odor may be sweet or pungent, pleasant or unpleasant, etc. Example: apples and oranges have a sweet fruity smell. In terms of taste, matter may be tasteless, or may have taste. Example: sodium chloride is salty, glucose is sweet. A word of caution. Smelling unknown matter. We should be very cautious, while smelling unknown matter, as it may be irritating or poisonous. Tasting unknown matter. Do not taste an unknown substance unless your teacher instructs you to do so. It may be poisonous. In terms of hardness, matter can be hard, or soft. Examples: diamond is the hardest matter known. Sodium metal can be cut with a knife. Wax, camphor, and soap are soft. In terms of brittleness, brittle matter, when hammered, breaks into smaller pieces. Graphite and glass are brittle. In terms of solubility, matter that dissolves in water is called soluble. Examples of soluble matter are sugar, common salt, and alcohol. Certain other matter, such as sulfur, does not dissolve in water, and is called insoluble. In terms of inflammability, matter that catches fire easily is called inflammable. Examples of inflammable matter are petrol, kerosene, and alcohol. In terms of boiling point, the boiling point of a liquid is the temperature at which there is a change of its state to gas. Water changes to water vapor at 100 degrees Celsius under normal atmospheric pressure. Hence, 100 degrees Celsius is called boiling point of water. While, the temperature at which alcohol changes into gas is 78 degrees Celsius. In terms of melting point, the melting point of a solid is the temperature at which there is a change of its state to liquid. Ice melts, that is, it changes from solid to liquid states, at 0 degrees Celsius. while naphthalene will melt at 80 degrees Celsius. In terms of conductivity, matter may be good or bad conductor of heat and electricity. Good conductors allow heat or electricity to pass through them, while bad conductors do not. Examples of good conductors of heat are copper, aluminium, etc. Whereas bad conductors of heat are lead, sand, etc. Examples of good conductors of electricity are copper, silver, etc. Whereas bad conductors of electricity are wood, lead, etc. In summary, there are important points to remember about matter. All living and non-living things are made up of matter. Matter is anything that can be perceived by the senses, occupies space and has mass. Matter made up of only one kind of particles is called a substance. One kind of matter can be distinguished from another by its physical properties like boiling point, or by its chemical properties like reactions with different chemicals. Matter occupies space and has mass, which has been proved by simple experiments. Classification of matter. Matter is distinguished into living and non-living things. Non-living things are classified into pure and impure substances. Pure substances are further classified into elements and compounds. Impure substances are called mixtures. In the states of matter, matter exists in three states: solids, liquids, and gases. Solids have definite volume, a definite shape, are not compressible, and are highly rigid. Liquids have definite volume but no definite shape, and are slightly compressible, and comparatively less rigid. Gases have no definite volume or shape, are highly compressible, and least rigid. Comparison of solids, liquids, and gases. Solids have very closely packed atoms with minimum spaces between them, and a very strong force of attraction between the atoms. Thus, solids have definite shape and volume and are highly rigid. Liquids have less closely packed atoms with more space between them compared to solids. The force of attraction between the atoms is less strong than in solids. Thus, liquids have definite volume but no definite shape, and are slightly rigid. Gases have atoms which are far apart with maximum space between them, and a very weak force of attraction. Hence, gases have no definite volume or shape, and are highly compressible, and least rigid. Conversion of state of matter. Matter can change from one state to another by a change in temperature, that is, by heating or cooling, or by a change in pressure. Terms involved in change of state of matter. Melting. The process of conversion of a solid into a liquid on heating. Ice, on melting, changes to water, which on vaporization, boiling, changes to vapor. The vapors, on condensation, give back water, which on freezing, gives back ice. Vaporization. The process of conversion of a liquid into vapor, or gas, on heating. Condensation. The process of conversion of vapor, or gas, into a liquid. Freezing. The process of conversion of a liquid into a solid. Physical properties of matter. Physical properties of matter include color, odor, state, taste, solubility, electrical and thermal, heat, conductivity and melting and boiling points.